Okay, so these expressions are all the same, and it doesn't matter which side of the pivot the mass is on. Sometimes you don't know which side of the pivot a mass is on, because sometimes you don't know where the pivot's going to be, as you'll see in a minute. Okay? But you have one expression. Now, if you use the absolute value, you'd have to make a decision every time about which side the thing is on. But if you use this, you always have it right. So, just to generalize, Ri is xi minus L over 2 times I, or whatever the position of the pivot is, okay? Okay. Now, we know what our forces are, so now we can easily write out the vector form of the torque.
I'm not going to shut the lights on.
So the vector form of the torque is,
You're welcome.
and I'm just going to simplify it. Well, okay. I can write it this way. More compactly, if I do this as a sum from I equals 1 to 3 of Ri cross MIG. I don't have to write out every term. Like if I got 15 of them, or 15,000, you know, probably want to use summation notation, right? If it's too many to write out, you need to know this notation. Okay? Anyhow, you work this out, and you find that it's the sum from I equals 1 to 3, and you can kind of deconstruct this. Well, your Ri is this, and your MIG is this, right? So you're going to have your Ri, which has got the Xi minus L over 2, okay? And G, mg, of course, is negative MIG J, right? So it's this times I cross negative MIG times the J vector. And if that isn't clear, take your notes and write it out. Okay? But this helps clarify what's going on without having to look at a long expression. Well, in every case, you're going to have an I cross J, which is a K, right? So this is the sum from I equals 1 to 3 of Xi minus L over 2 times Mi times J, and I'm going to factor out a negative G, because there's a negative on this term. And then if you write it all out, you would get negative G times X1 minus L over 2 M1 I'll leave it like it is. Plus X2 minus L over 2 M2 plus X3 minus L over 2 M3 times J, right? And of course you have a negative G on this. Let's see if that works out. is this going to be positive or negative for the picture that we have?
Negative.
Negative, right? And then it's multiplied by negative g, right? Which is going to make it a positive multiple, and it's, you know, I wrote j up here because, again, I'm not thinking and being careful. You got I cross j, which is k, right? So these j's should be k's. Okay, so this term is going to contribute a positive because you have a negative here times the negative of the g, right? Now, according to this picture, is the torque by the gravitational force going to be positive or negative?
It's going to be positive.
Positive because it's counterclockwise, or positive because r is in this direction and you cross that toward the force and you get a vector in the positive z direction, right? Okay? Each of these other two will be negative because these are to the right of the fulcrum, presumably the way I drew it. Okay? But with this expression, it doesn't matter which is to the right and which is to the left, because I could give you any values of x1, x2, and x3, right? They could all be to the left of the fulcrum. They could all be to the right. They could be mixed in any way. 2 on one side, 1 on the other. And this expression would still give you the correct torque. Okay?